So this is from the 2005 exam. It's type 6. Type 6 has to do with differential equations and slope fields. And typically the points break down where you have a little bit of slope fields and then finding a particular solution. That typically will count for 7 out of the 9 points. The last 2 comes from all sorts of different things. In this case, it looks like we're doing tangent line approximations. So A and B are pretty straightforward. C is a little bit heavier on the calculus, but drawing a slope field consists of evaluating the slope at any given point. So if I went to the coordinate 1, 2, I'd be asking the question, what is the slope at 1, 2? So the way this is evaluated is I go to my slope equation and I plug in 1 for x and 2 for y, and I see that this has a slope of -1. So at the coordinate 1, 2, I draw a little tick mark with a slope of approximately -1. Okay? And going through and doing this for every single point can be a little time consuming, so there is some shortcuts you can take. If you look closely at the slope equation, you can make some assumptions here. Anytime x is 0, I'm going to get a 0 divided by y, which is a 0 slope. So everywhere where x is 0, I have a 0 slope. Okay. I do not draw a slope anywhere along where y is 0, because y being 0 in the denominator would cause a non-existent slope, so we don't want to draw slopes there. Now fortunately for us, they haven't put little black circles for us to put slopes there, so only put slopes where they have the circles indicated. We'll do one more slope, just the long way. Let's do it at 1, 1. Stick 1 in for x, stick 1 in for y, and we get a slope of -2. So at that point, I draw a slope of -2. Now you don't have to be super precise on whether it's a -2 or -3. What you want to focus on is the relative steepness. I show that it's a negative slope because it's going downhill or decreasing, and it is steeper than my -1 slope. If you go through and you do that for all the remaining points, you'll start to see some symmetry unfold. And you get something that looks like that. This is worth 2 points. The first point comes from, do you have the 0 slopes correctly identified? So if all of those you had 0 slopes on, then you get 1 point. And then the second point comes from the non-zero slopes. So they're going to look at the remaining 8 slopes, and they're going to examine for positive versus negative slope, and they'll also look for relative steepness. And so the rest of them is worth 1 point total. Moving on to part B, let y be the particular solution, and they give us a initial condition of 1, -1. Write the equation of a line tangent to the graph of f and use it to approximate. So part B is a tangent line approximation question, and we learned at the start of the school year a function can be approximated by the tangent line, which is equal to f of c plus f prime of c times x minus c. That's our general go-to Taylor form of the tangent line, and that's what we're creating, a tangent line. We're centering our tangent line at 1, so if we write in f of 1 plus f prime of 1 times x minus 1, we've made our substitution for where the center is. And then we need to evaluate these things. F of 1, they give us, is a value of -1. F prime of 1, this is saying what is the slope specifically at the point 1, -1. So if we wanted to, off to the side, double check that number, 1, -1, we're going to stick that into our slope generating equation, and we get a slope of positive 2, positive 2. Which is supported with our graph shown there as a slope of 2. Okay. That's the first part of the question. Write the equation of the tangent line. The second part is use it to approximate f of 1.1. So f of 1.1 is approximately the tangent line at 1.1, negative 1 plus 2 times 1.1 minus 1. Which it is a numeric answer, and that's good enough for credit, a numeric answer, if you simplified it down to negative 0.8. Awesome, but I would recommend stopping at the point of right here. You've written out the approximation. Okay? You get 1 point if your approximation is correct, and you get 1 point if you have the tangent line correct. That's 2 points. All right, part C is pretty common for these problems. They want you to find the particular solution. So this is a case of separating the variables and then solving for y. So here's our given differential equation. If I separate my variables in step 1, I'm going to multiply the y across to the left-hand side and multiply the dx over to the right-hand side. And I have the variables separated. From here, we want to take the antiderivative of both sides. The antiderivative of the left is y squared over 2. The antiderivative of the right is negative x squared. And both sides have a constant, but I'm going to combine those constants into 1 on the right-hand side. Now, at this stage, there is some deviation. Some students will solve for y first. I encourage you, after reflection, to plug in the initial condition first to solve for c. So our initial condition was f of 1 is equal to negative 1. So we're going to plug that into this expression. Negative 1 squared over 2 equals negative 1 squared plus c, which gives us 1/2 equals negative 1 plus c. Therefore, c is 3/2. So we found our c value by plugging these in, doing the algebra. So our path to our particular solution now looks like this, and our goal is to solve for y. So solving for y, the first step I'm going to take is multiply both sides by 2. And then square root both sides. Now when we take the square root, recall that it introduces an absolute value, which consequently introduces a plus or minus. We need to decide between a positive or negative root, and that comes from the fact that our initial condition was a negative y value, so we want to have the negative root instead of the positive root. And that's a very subtle detail right at the end. This problem is worth 5 points. You get your first point for separating the variables. You get your second point for having the antiderivatives correct. You get a third point if you just remembered to include plus c. It's a pretty easy point there. You get your fourth point if you plugged in the initial condition. And then you get your fifth and final point for correctly solving for y. It's very common that these problems will break down with those same 5 points. Sometimes it's even 6 points if you can do this correctly. Thanks for watching. Be sure to comment, like, and subscribe.